So we're going to pick up where we left off. I asked you to load the glyco. I did some searching. It now works. All right, so there is a possibility that if your environment isn't updated, so like you load a data set and it doesn't show up in the environment window, when you create objects it doesn't show, it's a possibility that maybe this was changed. So up here is a refresh. If you click on the drop down arrow, it should refresh automatically. If it's a manual refresh, then I don't think anything's going to update until you hit that refresh button. So you can try that. If that's not the issue, then I have to keep searching to see what other possibilities there are. So, all right. We left off with glyco data set. Did you load it? So I think I said save it as glycogen. So let me get mine up. Right. Looks good. Strings as factors. Hit import. Oops. I didn't save it with the correct name. No big deal. I'm going to copy that line. So this is 3 of them. So I'm going to copy and paste and just change that to glycogen. And I am running this, so now glycogen's available. And then I also said, view the variable names. So that's what we have. Yep. And don't forget, copy and paste this code into a chunk so that we have it. Read the glyco.csv dataset and view the variable names. All right. So, y'all got this? Yes? Not yet? Yes?
Sure, you're good.
Is there an error message?
No, I'm good. I just haven't.
All right. What's that? Oh, I did names. Did you do? Yep, something like that. That's okay. Again, I'm going to warn you that if you have this glycogen in our actual markdown document, when we knit it, it will actually print out the entire data table. So I had some 100 plus page exams turned in, and 80 of them were a data table. So my statement here is going to differ from yours because I have different folder structures, but we still were able to read it in, and we have it in as glycogen. All right, what's his reader? So a new version. So RStudio became version 1 a couple years back. Before that, we were using experimental version. I think it was like 0.9, 0.92, 0.93, something like that is when we started using it, which was mostly functional. I mean, it worked. Really made our life easier in reading data sets. With version 1, they started a new thing that reads in these text files, the CSVs, TXT files, as something called a Tibble data frame. All right? This puts it in not technically as a data frame, but as this different object that holds the data frame inside of it. I'm not entirely sure what the advantages are. You can do a search for it and look it up to see any advantages, but the disadvantages that we encounter is that if I run this command, head data frame, it doesn't really show, well, if you use the data frame, the name of it, in a function that checks to see is this a data frame or not, that function could fail. All right, that's functions in R. This part doesn't default show the entire data frame. Yeah, that's true. So if like we load it in and we type glycogen to see did it appear, it's not going to show the everything in all the data frame, or it doesn't show all the data, and sometimes you want to see it. But it's this part that really causes things to fail because it's not a data frame, it's a Tibble object. All right? Some people use it. All right? Other people have gotten around it. But the scripts that I've written, some of the scripts that you'll find online, they need a data frame. So what I recommend doing is just using the import data set from base, and that way we can avoid any of our functions that I give you from failing. So this is why I present it. If you're like, what is this readr? I'll say one of the advantages that they advertise is that it's very easy to restructure your data frame, restructure the data with one of these Tibble data frames. I don't really need to do that because I think Excel works a whole lot better. I think you're going to be more comfortable working in Excel. So if you need to take data and rearrange your columns, it's pretty easy to do that in Excel. All right? I think it would be a whole lot harder learning how to actually do it in R. So that's what we're not going to use it. All right, moving forward, we have glycogen, and we have our glycogen data set right here. All right, we're interested in glycogen counts, glycogen content of the liver. Question is, how do we reference that? How do we reference that variable? Right? Seems like you can just reference glyco to get that vector of data, right? So go ahead and try it. Type in glyco, see what you get. What's it say?
Glyco's not found.
Glyco is not found. Where is it?
The data frame.
It's in the data frame. It's in the data frame, but R can't see it because it is in the data frame. The only thing that R sees is the data frame itself. So when we reference variables inside a data frame like this, we're going to have to tell R where those variables are found. And I've referred to this as referencing variables. All right? So we kind of have that. Typically, we type in the object name and it returns the object. Well, glyco is not really an object. It's not an object in R. It's an object in a data frame. All right? So, I go through it. How do we do it? Well, we reference these variables using the $sign. The $sign tells R, hey, this is found within some other variable. So we're interested in the glyco variable. All right? That glyco variable is going to be found within our glycogen data set. All right, so if we wanted to look at heights of the women or the weights of that women data set, it's already built in. If we type in height, R is going to say object's not found. If we type in weight, it's going to say object's not found. So if we're going to get it, what we have to do is actually tell R exactly where it is. So let's do that women data set just to kind of demonstrate it. Right. We're going to view the height variable in the women data frame. All right, this is what we're going to do. Let me scroll. All right, so I'm going to type in height. We know it's there. We've been working. We saw the women. We know it's there. I'm going to run it. We get an error. This function returns an error, right? Because, why? So it returns the error because R doesn't know that height is in the women data set. We must tell R where this variable can be found using our $sign. The format is data $sign variable. Which says, and I'm going to put this in, well, I don't know if this is going to knit. I don't know if the $sign has a specific function. We'll try it out. So this data $sign variable says return the variable vector, I guess, that is found within the data frame, in essence. So that's like verbalizing. If I ask, okay, women $sign height, tell me what this function does, it says this will return the height vector, and height is found in the women data set. All right? So now I can do women $sign height. Now we're in the proper format. We're telling R, I want that height variable. Give me that vector. R doesn't know where it is, so we tell it it's actually found in the women data set. So women $sign height is giving its location. Now when I run that, I get my vector of heights. And then a vector of weights. We get our vector of weights. All right, so it's all, R needs to have it in memory. It has the data frame in memory, but it didn't keep track of what the variable names are. It's only when we tell the R to look in that data frame will all of a sudden it look and find that variable that we're interested in.
Is that partially because you could have the same, like you could have height for women and then if you had another data table of men?
Yep. So you can use the same variable names in multiple data frames. And this allows us to avoid like really confusing R. That's kind of how we approach it. Now for practice, view the, I think the glycogen. Is that what the practice is? View the glyco variable that's in that glycogen data set. Yep. Which one?
I can't see the lower row.
Like this? Yeah. Alright, so we're putting in our practice. Go to RC. Download that one. RC desktop. Free desktop. And then you're gonna run that file. Did you install R? Let's see. It may ask if you want to install. It's installing right now. It should ask you if you want to install R. Okay, try to start it, see what it does. Okay, so it takes you there. So now what you do is download it. Then we're going to scroll down to US. And then I typically do same thing. And you can install it. And once it's installed, RC, you should be able to start. Alright, how'd it go? Alright, so hopefully you figured or saw something that's rather interesting. Alright, so if I type in glycogen and just start typing it, hold on, let me remove the glyco. Actually, no, this will be a good demonstration because I have glyco and glyco is found in the data set. Alright, as I start typing it, RStudio will list what it's finding in memory. This goes for functions, this goes for objects that we create, this goes for objects that we import. So these two are in my environment. Alright, so what I can do is use my arrow to highlight glycogen, and then I can hit the tab key and it'll auto-complete. Same thing with the variables. As soon as I hit the $sign here, R opens up a list of all of the variables in my data set. And I want the glyco, so I can easily just go right down to there and hit the tab. Tab is an autocomplete option. You've probably used autocomplete on cell phones. This is the computer version of it. So this is how I do glycogen, glyco, there's our vector. No problem? Right. So we did that. And again, if you get error object glycogen not found, check the name of your data frame. Alright, so important tips. R is command line driven. It's based on the Unix operating system, which means there are some rules for us. Number one, spelling matters. These are two very different terms. R will see these things very differently. So our data set was women. All right, if we use woman, R is going to say object not found. It doesn't know what it is. We misspelled it. So spelling is critical. Capitalization is also critical. This one's capital, this one does not. R will find this one, it doesn't know what this is. It's completely different. Capitalization matters. That's why when I do a lot of my stuff, I keep it lowercase. So that way it's one less shift key that I have to hit. If everything's lowercase, I don't have to worry about capitalization. It's just everything's lowercase. Note, lowercase h, capital H. Those two are different. One of them will work, one of them will not. Because again, capitalization matters. Same thing here, we're using a function. The function in R is mean, a lowercase mean. This works, this does not. So, first thing, if you get an error, check your spelling, check your capitalization. Maybe something is there. We had one last week, right? When we used the C to make a vector, it was a capital C. Capital C is not the same as a lowercase c. Or at least the computer sees it as two different things. The other thing are the correct symbols. The symbols matter. All right, if you use double quotes, use double quotes to close it. If you use a single quote, use a single quote to close it. Don't mix and match them. Also, copying and pasting from a document may actually paste the incorrect quote symbol. It might look like a quote. It might look on a quote on your screen, but it has a different code that the computer sees, and it says, well, that's not a quote. So if you copy and paste something that has a quote, so something that I give, or something that is in a PDF or a Word document, go back, delete the quotes, and type them in by hand. That might fix the problem. If you're working in here, and possibly on the console, probably on the console is when you would be working with it, and you hit enter, and nothing shows up. And then you go back and retype it, and you hit enter, and nothing happens. It just makes a new line. Pay attention to what's at the bottom. If you're in the console and it's a plus, it means R is waiting for more commands. All right, you didn't finish it. Fortunately for us with the R Markdown, our chunk is just going to fail. It won't run. And it'll give you like a missing symbol or inappropriate symbol or something like that. And what that usually means is that we didn't close our parentheses, brackets, or braces. All right, so that's also something we have to pay attention to. And that's why I said when you run into errors, you sit there and it's like, I'm doing it right. It's just how it appears. Sometimes it's good to have someone else look at it and they can say, oh, you've got a capital. It's like, oh, crap. Completely missed that. So check it out. What happens if you need help? For any of the commands, there's a couple different ways to do this. The way that I learned, and it's still just a bad habit for me to do this, but it's to type question mark and then the name of the command. It works the same way with the data frame. You type the question mark and the name of that data frame. So like here, I open up the console and I say, okay, I don't know, I want to know what this women data set is. I can type in question mark women down at the console, hit enter. And what that will do is open the help file in this lower pane. To me, that's easy because I didn't learn with RStudio. I learned with the console. Right? I learned with the console. So this is how we found our help. You can also type help and then in parentheses, put in your function name that you're interested in. The other way is this. Open up your help window and just do a search for it. Let's do, so I did a search for vegan, hit enter, and the help window opens up a bunch of different stuff. Let's say I want to know mean. I hit enter, it opens up the arithmetic mean. So both ways work. And this kind of gets you to, functions, gets you to the data frame. For the functions, the most likely scenario that you'll encounter is you don't fully remember what all has to be included. Or there's a switch, so it's like, okay, I don't remember what this na.rm is. Or perhaps it's like, I know I have to put something, and you're putting in rm.na, and it's like there's a problem there. Look at the help file, and you'll see. Oh, here's the format. Type in the mean, I give it the vector, na.rm equals false. Oh, that's what it is, I've reversed it. That's going to be the most likely scenario for you in this class, and probably moving forward. Questions? So I do have, I did the mean command, all right? But what about the Dune data set? How do we access that? Oh, same way. So go ahead and see if you can find the help file for the Dune data set. Remember, the Dune data set was in that vegan package. All right, did you find the Dune? Yep, that's right. I just heard the answer. All right, so question mark mean. This will open up your help file. Dune doesn't work. Dune doesn't work. The vegan package has to be loaded in order for it to work. All right, or at least it used to be able to. We'll check it. But even if you do the data, Dune, and package equals vegan option so that Dune's accessible, so like you can see Dune's accessible here. All right, but the package, go down to vegan. Vegan's not loaded. So I get this error. All right, I get this error. It says you can try question mark Dune. Okay, let's try that. See if it works. No? Nothing. So your best option will be actually just to go into the search bar and type in Dune. And what you'll get then is this option, the help pages for vegan Dune. So this is, these colons are basically saying we've got this package and then we've got items within the package. So now I can click on it and this opens up the help file for the Dune. So that's probably your best option. So let's load it. Yep. Once the package is loaded, this will work, but the package has to be loaded. Does that computer not work?
It just won't open anything. It's like the file that we were talking about.
Oh, okay. IT, I bet we'll get here around 3. So we'll check the computer. All right. Other comments with this. Google's your friend. Google's your friend in this class. I don't know how many times I watch students struggling for 15, 20 minutes on a single question, a single question on an exam. And I'd see them just sitting there. I'm like, what are you doing? What's wrong? I'm getting an error message. Okay, what are you trying to do? Well, I think I've got the command, it's not working. And I know, it's like we've covered it several times. I said, did you Google it? Like if I say, calculate the mean of a variable, did I say, did you Google mean and, calculating means in R? And there's an overabundance of information because there are a lot of stats classes that use R. And a lot of those classes post stuff freely available on the internet. Between YouTube, between like regular web pages and so forth. So if you get error messages or you don't remember how to do something, use Google. Maybe the code will say, oh, I remember when we did this. This was on this day, and it gets you back into your notes. All right, and lastly, don't be afraid to ask for help. All right, don't spend an hour trying to figure out an error message. Spend 5-10 minutes, look over it, check your capitalization, check spelling. All right, check to make sure you've closed that all of your parentheses and brackets and stuff, and then shoot me an email. All right, in that email, I need to see the error message, and I need to see the code usually. Say, okay, this is what I'm trying to run. I'm getting an error message. Oftentimes, it's best you can just kind of send me your RMD file, and I can take a look at it. I can see if I can replicate it on my end. Usually it does. It works. Other times, I should say, no. Usually I can replicate it on my end. Other times it works just fine for me. It's like, well, the function works. The problem was the data frame. It's like I read in the data correctly. It's there. Issue was your data didn't get read. Go back and check that one. So that's, it's going to save you a lot of grief and stuff. Mistakes are going to happen. I do it all the time too. Again, capitalization, spelling, it happens. And that's where you need like a second pair of eyes just to kind of spot them. It's going to apply on the exams too. If you run into error messages, you can always ask for help, and I'll get you through that. All right. So, looking ahead, we're going to be creating vectors and data frames. We're going to, and that's going to be next. It's going to just be practice to kind of reinforce what we're learning with R. And then we're going to get into the stats where it's like summarizing table, making some tables and figures. They won't be super nice formatted tables. They will be tables that we can quickly look at it and allow us to make predictions of whether or not we'll get significant p-values. We'll learn a bunch of tests to get our p-values, and we'll make pretty annotated output. So a big part of this class is learning how to present our data as well, presenting the results of our statistical analysis. So anytime as we move on, if you get errors in class or lab, stop me, raise your hand. If you're getting it, I bet somebody else is getting it too. All right, questions? All right. Let me make sure it's posted. Blackboard. I had to change my password last week. I'm struggling to remember which one I have to type. That's probably the number one reason why people pick easy passwords. Because they make you change it every 6 months. All right. Here's what we're going to do. We're going to move on, and I'm going to end up releasing the homework. All right. We're going to practice data import in R. We're going to show you how you can take some data, get it into Excel, save the Excel spreadsheet as a CSV, and then import that. All right. But But before we do that, and then we're going to knit the document too. I'm going to show you how to knit, and then we can go back with this first file that we've made and practice to see if we can get it knitted to a Word document. All right. So the folder structure, I'm going to repeat how I made my folder structure. So on my network drive, I had a biometry folder or biostats folder. All right, you say bio 4480 or whatever. But then I have an R folder inside of that. So I'm going to have, inside that biometry, I could have like the PDFs of the presentations and stuff. All right. Then I'm going to have an R folder. Inside that R folder, I have a folder for scripts, folder for data, folder for figures, and a folder for markdown. Do you need a figures folder? No, you don't. All right, that's for me because I can make figures and export it as JPEGs, as PNGs, and so forth. You don't need it. Do you need a scripts folder? Probably. As we get into scripts, functions that I wrote and give it to you, those will probably be ones where you can save it in there. I call it scripts. Yours could be like functions or something like that. And we'll have one file for every function, so that way you have a copy of it. But what's important is this markdown folder. All right. So inside this markdown folder, that is where we will save our RMD files. And that's going to be where we save this Word template.docx file. All right. So there are two things we're going to download first. One is this file on Blackboard, and the other is the Word template. So let me go to, bring our Blackboard over. All right, so we're in part 2. I've got Word template.docx. All right, I'm going to save that as. And then you're going to go to your network drive, documents, wherever your biometry folder is. I've got R, and then I have Markdown. All right, and I already have the Word template there, so I'm not going to save. I'm going to hit cancel. But you want it there. And then you're going to do the same thing for your R data import practice. So you right click it, you save the link as, you get to your network drive, get it in Markdown, I'm going to hit save because I don't have it there. R data import. Now once it's downloaded, I will open it in RStudio. So here it is. Alright, you can see that I have modified everything. Alright, so it's all set up for us to practice. Now you're going to have to update the date. You'll see I actually have on the exams and some of the homework, I have a function that will automatically print the current date whenever you knit the document, which is pretty cool. It's pretty cool. But you can update the date. And you can leave everything else the same. We're specifying our Word template, the Word template to use when we knit it. All right, so this is what we're going to use. We're going to use this file to work through this practice. Use this file to work through the practice. And then we'll knit our document at the end to make sure everyone can knit it. So the first thing that we're going to do is link data. All right, so this is a data table. Let's say you pulled it from a notebook, lab notebook, or maybe you're interested in doing some research with a faculty member, and they give you this table and say, here's this table. I want you to, we're going to analyze it. We're going to analyze the table or something like that. All right, so we need to get it in R. Well, you don't have a file, you actually just have a folder, like on a regular piece of paper. So we need to get this into a format where we can import it in R. Easiest way to do it, use Excel. All right, use Excel. So go ahead and open up Excel, and we're going to recreate this data table in Excel. We don't need our lines, we just need the regular data. All right? And as you do this, there are some rules for Excel. One column per variable. That's rule number one. Rule number two, our header row. That column names, right? The column names, the variable names, do have limitations. No spaces. If there's a space, R will add a period in place of that space. So if you want to have like different letters or different words, you know, max temp, right? Max temp. You could use max period temp. You could do max temp all word or all one word. You can use max underscore temp. All of those will work. All right, but avoid the space. Number two, don't begin that variable name with a number or a symbol. It should be a letter. If you don't, you'll get an error. I don't think R will import it. Really, we should avoid any symbols. Sometimes the symbols serve as a trigger for some function. All right, so just avoid symbols in general, the exception being underscore or period. And this is a preference, but I generally avoid capitalization. You can use capitals if you want, but I typically avoid it. So get that table into Excel, and then we're going to save it as a comma delimited file. So here's this. Let me open up my Excel to get this working. Where would I saved it? Yep. Okay. But that's an R&D file. You don't import data set. It cancels. It cancels. The file, folder file, and then you go to that. There you go.
And then
And you close it. Good. Right. Try it again. Okay. See if you can drag and move it over there. There it is. When IT comes in, we're going to show them that. See.
thank you.
All right, let's see. What's that?
Which CSV, Macintosh or MS Office?
Probably I'm not sure what the difference is between the other ones.
You saving it under your data in that folder scheme?
Yeah, you can do that. So, I'm going to show you. Here's mine. Oh, wait, let me enlarge it. Definitely makes it easier. First up, I'm going to save it as an Excel document. Excel data. Data.lake. I'm going to save it as Excel first. And this is what I strongly suggest you do whenever you're actually working in data, because the native Excel spreadsheet will allow you to save multiple sheets. It'll retain all of your all the functions and everything. So it's very easy to do that. The CSV only saves one sheet. So whatever sheet we're on, that's the only sheet that gets saved. So now that I have it saved as Excel, I'm going to do the save as. I'm going to browse to my location. I'm already there, but it's under the save as type here. And what we want is this CSV comma delimited is what my preference is. You could use a tab delimited, but I like the comma delimited, just a little bit easier. So I click on the comma delimited, CSV comma delimited. So that's going to be the file type that I save it as. I call it data.lake because that's what I'm going to import it as. And then I hit save. And you get this warning. Some features might be lost if you save it as a CSV. We know that. That's why I saved it first as an Excel, so all features are there. And then I'm only saving this worksheet as a CSV. So, didn't quite save as. Yeah, it did. It saved it. It already saved it. So you can do don't show this again if you want. Never gotten around to clicking that, but now we have the CSV. So once we have the CSV, now we can import it into R. So go ahead and import it into R. Make sure you can get it. And that is already on here. So lake data import, after creating the lake data in Excel, import it into R. So this is meant for the code that gets the data table, or the lake data, into R. Copy it, paste it into that chunk.
When you're creating a table in Excel, do you still not use capitals?
Yeah, because when we import the data, it will import it as whatever we typed. If you're making a table to put in a paper and make it look nice, then yeah, capitals would be nice. And the lines would be nice and everything. Alright. If you get it, the next one is roach data. So now this is presented in a slightly different way, but we still have to abide by our rules. 1 column per variable. What's your error? Oh, yep. So you're gonna have to do your importing. Text base. You're gonna have to do this. Go down to your network right here. Click on that. Go that. Oh, that's an XLS file. That's a CSV. Okay, yeah. So hit cancel. Hit okay.
Oh, wow.
Okay, use import data set from text base. No, not Excel. Text base. That's what I'm about to see. Don't forget to collect that strings as factors. And then you can change the name instead of it being Blake. I think I asked you data document. Now, big strings as factors. Yep. What's that? Oh, yeah. Okay, let's go back and import it again. So it didn't quite import correctly. I didn't do that. Find your, is that the CSV file? Okay, heading. Oh, that didn't quite save correctly. It canceled. Let's open up that file again in Excel. No, just type it in. Yeah, so, here, let's see if we can get this. Copy this. Paste it. first row. Now just resave it as a CSV and it should work. Did you get data.roach? Working on it. Save as. Okay. So I imported data.lake. That works. Got it imported. I have the roach that needs to be imported. So I made it. Actually, it better go this way. Call it data.roach. Alright, strings as factors. Copy and paste. Make sure I get everything. Alright, so then I've got these two things that are aimed at checking to see if we did it correctly. Now, we did have give me some time to do this, but in this, the roaches, technically left and right is the variable. It's the nominal variable of which side was measured, and then the length is actually that third variable. So technically speaking, we have one label variable and then one measurement variable, but what we're going to do is kind of assume that we have a left variable and a right variable. Just going to make it a little bit easier for us, because the whole point of this was making the data in Excel, then transferring it into R. All right, so first R is making a table. What this is going to do is create a frequency table, and we have to give it an object name. And that object name is either going to be a vector or it's going to be a list of values. All right, so what we want to do with our lakes, we want to make a frequency table of the number of lakes with the specific dominant predator species. So we'll talk about frequency tables later this week. All it is basically a table of counts. It's a table of counts. So we're going to make a data table, or we're going to make a table of the predator species to figure out how many lakes actually had that as the main predator species. How do we do it? Table objects. So go ahead and try to do that on here. All right. Let's go ahead and try to make it. Yep. Oh yeah.
Go.
No. Is that a vector or a list? So pay attention to the objects. Yep. So pay attention to the objects. So the command is table and then an object. And the object for the table is either a vector or a list. All right? It's either a vector or a list. So I'm just going to demonstrate some information here. So I have data.lake. There's a command called str that lists the structure. So I'm going to do structure data.lake just to view it. And that tells me that this is a data frame. Is that a vector or a list? It's neither. It's a data frame. What do I have to give that table function? Vector or list. So the next question then, what's a data frame? What do we define a data frame as? A collection of vectors or lists. All right, so what we're looking for is that. The list of species lists our top predator in that lake. So we want that. That's what we're looking for. A table of species. Question is, how do we access it? How do we get a table of species? So I could do this, table species. Do you think this is going to work? Why not?
Doesn't know what species is.
Yeah, it doesn't know where it's found, right? So how do we tell R where to find this? Now we get it. Now we get it. Right? All right. And same thing's going to apply to this next one. Oops, hold on. That was the roach. Let me copy. Let me move that up to here. There we go. That's better. Roach is different. All right. So what we want with the roach is to calculate the difference between the left wing and the right wing. And it doesn't really matter if you do right minus left or left minus right. It doesn't really matter. All right, but what we're going to create is a new variable. We're going to call it difference. All right. And then we have to figure out what the difference is. And it's going to be the same thing. So data roach. We've got a column with our left measurements and a column with our right measurements. All right. If I do left minus right, is that going to work? Why not?
Doesn't know what left and right is.
Yeah, it doesn't know where it is. So how do we tell where to find it? Data.roach, $left. Data.roach, $right. And we get our difference. So in our chunk, we're going to make that difference, and then we make a histogram. And our histogram follows similar format, where we need a vector of numeric data. So a vector of numbers. Difference did that for us. All right, remember, we did the difference, that subtraction. In the intro to R, we used addition. We made A and B, right? And we said A plus B equals Z, right? That worked. Same thing, we're just making a difference. We have difference, which is a vector of numbers, right, which is a vector of numbers. And then, when I run this, I get a histogram. It's not the prettiest of histograms, but it's a histogram. I think I gave that function in here. Yep, hist of the object. And there's a lot more to the histogram. There's a lot more histograms that we'll learn when we get to it. So we can add more breaks to it. We can adjust the scale. We can change it from a raw count to a percentage. So this is a raw count. We can do like a percentage of the total. Right? There's more things. This is just to kind of get you practice getting used to using the $sign notation. We'll go into specifics on the hist function. All right. So let me do this. All right. Edit. Let me set a due date on this. I'm going to go ahead and release the homework, even though we didn't quite finish. All right, so in the homework, I have intro to R. Whoa, hold on, let me check. Unavailable. Why do I have it called key? That's problematic. I may have uploaded the wrong file. I guess we'll open it. It is. I uploaded the wrong file. Let's see if I can, I'll get this updated, but we didn't knit the document yet, so I'm going to set the due date for this homework for Friday, because on Wednesday we'll kind of finish out this document, we'll knit it, and then we'll practice knitting the note document that we created, the intro to R notes, just to make sure we can do that, and then at that point you should be able to knit the homework document. Hopefully. Let's see here. Save link as. I can't believe I did that. Good thing I caught it. Man, you guys are using exactly the same thing that I would have done. Yeah.
Hi, I'm with IT.
How are you?
Sorry if I interrupted y'all.
No, we're finishing up.
Okay.
We've got 2 computers over here.
Okay.
Show her the one where the Excel didn't work. No. Oh, there is a blue screen on that one?
Yeah.
Great.
Oh, you're good. No rush.
Is there a way to make the title more descriptive without messing with the data too much?
What do you mean?
So if you wanted to change the title, is there a way to
Oh,
go
like
in?
for the graph?
Yeah. Is there a
Oh,
way
yeah,
to
yeah,
go in and
yeah.
do that?
Oh, yeah. I'll show you those.
Okay.
I'll show you those, no problem. All right, so I think
I'll just wait till you're done because it's going to take a little troubleshooting. Okay.
did it work? Did Excel work on that monitor?
Well, like if it's minimized, it does, but like once you maximize it, it's.
Okay, that's jacked up.
That's going to take a little troubleshooting, so I'll wait until.
I have an error too, so I'm gonna.
Okay, I'll see it. All right, so the homework's posted. This is going to be we'll practice like uploading the PDF, but the R Markdown file, the RMD file, has all of the question marks, and you'll see that it's practicing what we did. All right, just giving you repetition on importing data. I would have had this due on Wednesday, but we'll do it on Friday, and it'll be due at the end of that day on Friday. So ideally, you have it done for class and you have no problems. But if you run into errors knitting it or uploading it, ask at the very beginning of class, and we'll get it fixed. And that way, if we figure out what's going on, you'll still have time after class to fix it and get it right. All right? Just make sure you save your RMD file, and then we're good to go.
If we save this, like on our OneDrive, when we open this this on our laptop?
I don't know.
Save?
I don't know if you can save it to the OneDrive here. Anthony tried to do it, right? You tried to save it to your OneDrive and it never really transferred over. So maybe if it's set up, if the OneDrive link is set up on the desktop, maybe it'll work.
If we log into OneDrive on the desktop, do we have to log out every time?
Good
Or
question. I don't know.
should someone else access it?
I don't know. No idea. I don't know. I've always,
I wanna switch to using
I've
my
saved it on my
laptop.
Dropbox and then,
I wanna switch to using my laptop, but I don't wanna have to redo it.
yeah, no, well, you can save it and then email it to yourself. That's a way to do it, right? This is the computer that was like randomly shutting down.
Okay. I just want to hear if you want
Okay. Oh, here's your problem. The difference is that they ordered it as P1. So let's go back to the data set. You gotta go through this. Oh, okay, yeah, so you didn't set it up in column format. So one variable per column, gotta be vertical.
Oh, yeah, I did the
Yep. Yeah, probably. Yeah, so if you drop down the row to data, it's probably gonna be like E1, yep, see? Yeah, so if you convert it, we make it vertical, so ID is one column, left is one column, right is one column.
language or yoga?
Now looking for a break?
I'm a CSU, but I have no experience with learning how to program for You'll figure it out. Studying.
You capitalize right, but not left. That's gonna work. So yeah, if that fails, look at your difference, it was empty. Right. So if it was empty, you never really created it, look at that date. Makes sense. Yep, just make sure you save it and we'll pick that up on Wednesday, maybe and get it knitted and everything. Knitting will be the No. It's a table and an object, so we want to do frequency table of our species down. So we want species there, because species is a vector, right, or a list. But R is not going to be able to find it. So we have to tell R where we want species. So it would be table. Table, that's our function. And then parentheses. And then how do we reference species? Yep. range the same thing. But with histogram, we have to make a new object called difference, and then we can make a histogram distance. All right, and we're gonna take up on that. We're gonna see it review again, see this, and then we'll try to make that.
That one was hard to write.
Ooh, hold on, let me stop. Let me stop streaming.